We'll be discussing ArcGIS 3D and BIM, where we are today and the big improvements coming. This is a continuation of our 2018 webinar series, and we are excited to have another great presentation with excellent content that I think everyone will enjoy. This webinar is being recorded. Keep a lookout for the Q&A session at the end of the webinar. So if you have any questions, you can type it in the chat and we'll get to that at the end of the session. Without further ado, I'll turn over the presentation to Patrick, and thank you again, Patrick.
Hi, good afternoon, everyone. Thank you for having me at this month's webcast. I'm glad to do it. I'm glad to tell you all the things happening currently with 3D and BIM in the ArcGIS platform. I have way too much content for even an hour, so I'm going to go pretty quickly because I'd rather tell you a lot of things quickly than not enough over the time that we have. So I'm just going to jump in. So I get my slide deck ready to go here. All right. So what we covered today is, just like the title said, where we are today. We're going to focus in mostly on the desktop, 3D and ArcGIS Pro, a tiny little bit of City Engine. Then we're going to take a look at Web 3D and our web scene technology. We're going to take a look at the 3D web services that make up those web scenes. We're going to look at some of the 3D solutions coming out in ArcGIS for local government. And then we'll talk a little bit about where we are with BIM today. We certainly can do it, and I'll show you some examples of that. But more of the BIM talk is going to be around the big improvements coming, specifically regarding our ESRI Autocad partnership that was announced last November. I personally have been involved in some of those follow-up meetings with Autodesk. I spent a week in our headquarters last week, and I'll be back out again next week to kind of figure out what that whole thing means as far as software integrations, partnering opportunities, and everything else that comes with a big partnership between two big companies. Then hopefully I'll leave some time at the end for some questions, and hopefully I can answer them all. So ESRI users are adopting 3D all over the place based on the number of web scenes we see online, the number of 3D layers, and the number of downloads of our software. There is a huge uptake of 3D. They're collecting and processing all kinds of data. They are constantly contacting us and telling us to make 3D more functional and easier. We're going to dive in and take a look at the current 3D capabilities. Most of these are kind of the ones I think are the most important for new 3D users to know. And then I'll go through a lightning round of all the other functionality that's been added for 3D in the last year and a half. I could spend an hour on that. First, some highlights with ArcGIS Pro. It is our flagship desktop product now. It combines 2D and 3D in one app. There are no more the days of multiple applications of ArcMap and ArcGlobe and ArcScene to do GIS. We have one application that does 2D and 3D GIS. We've rebuilt the display engine with 3D in mind, a much better user experience, certainly for 3D. The user experience for 3D is night and day from what it was in previous versions of our desktop. It is cloud ready, so it is the place where we create our 3D scenes and where we publish those 3D scenes or the data as 3D web services. It's 64-bit multi-threaded and performs a heck of a lot better than 32-bit ArcGIS desktop does. A couple things in particular when we're talking about 3D in ArcGIS Pro is we have this concept of a local scene that has local projected coordinates like New York State Plane and others, and a global scene. That's more Mercator or WGS 84 and intended for global scales. I'll show a little bit of this in the demo coming up here in a minute, but you can kind of switch back and forth between a global scene or a local scene. It's really just one scene. It's the way that we're opening that scene is how we want to work, is just depending on how we want to work. Layers in 3D have additional properties, as you would expect, than they would in a 2D map, particularly around the elevation and how we're going to place those features either on the ground, relative to the ground, or at an absolute height. In that case, the geometry itself has Z coordinates already kind of built into it, and it knows exactly where it sits. With 2D content, which is still the vast majority of what we have out there, that content can be draped on the ground or converted into 3D by applying various properties within the scene. Extrusion, elevating that 2D data set to a certain elevation. We a lot of times start with 2D data to create our 3D content. In ArcGIS Pro, we have this idea of what they call a ground surface, but we do support multiple elevation surfaces. So we can have a surface that represents the ground. We can have a surface that represents tree canopies. I've even create underground surfaces representing soils and other things underground. Navigation as well can be done above and below the ground surface. When navigating in 3D, it can be challenging. There's a lot of things you can run into, have to kind of go around. It requires a little bit more of a precise navigation approach. And so to address this, we've introduced what we call the Navigator. This works for both 2D maps and 3D scenes. In particular, I'd point out the one in the middle here says look around. It's particularly useful in 3D situations when we're, say, up against the face of a building and we want to kind of look around and see what you could see from that window, or in a confined space like a utility trench where we have content all around us, but we still need to be able to kind of turn our head in a certain direction. So this kind of provides that precise navigation that you definitely need to have a good 3D experience. All right, let's take a quick jump into a demo. Give me 1 second here just to bring it up and make sure it's displaying. All right, looks like it's displaying. So the first thing I'll point out, just to kind of reinforce some of the initial slides we showed, is in the catalog pane of our project, and this is essentially the project structure. We have maps and all the toolboxes, databases, folders, tasks, anything additional we'd add off of the insert toolbar, various new maps or scenes, connections, etc. But in here, we have a number of various 2D maps, and they're represented by the 2D map icon and 3D scenes. And you can tell whether a scene is local or global by the icon. If it's a globe icon, it's a global view, global scene. And if you have this little city icon that you see here, that represents the local view of that scene. So it's shown as one scene, but it can be opened in either way, global or local. So a local view. So let's take a look at that. Here is pin that here. Here's a global view of a 3D scene, zoomed far out, and you can see the curvature of the Earth there. So there is a globe model that the content is then projected onto. Whereas a local view, in this case, using New York State plane as our current XY coordinate system, that is a planar projection. And so you can see as we zoom far away, we do not see that curvature of the Earth, and we're working in local state plane coordinates. Let's see. In this other 3D scene here, we'll take a look at the various 2D layers and 3D layers that we can utilize in a scene. And so we'll have, in every scene, we'll have a grouping of your 3D content and your 2D content. Your 2D content are your typical 2D feature classes, draped on the ground, results of your buffers, any of your elevation rasters that you want to show in the scene. Right, so Central Park boundary, we can go to the elevation tab and it is draped onto the ground surface. We can offset that if we need to by any units. However, our 3D layers, whether those are polygon feature classes, line feature classes, 3D multi-patch feature classes like the buildings, will have additional options. So here under the elevation, we have these sight lines, result of an analysis we did at an absolute height. So they have, each vertex has a Z value. We could also place those on ground or relative to the ground. So we really have full control over the content, where it's placed, and the kind of order of the stacking of various data in our scenes. Let's take a look at some additional things here in 3D scenes. Our scenes, we can kind of link these scenes together, so we can take one view here and another view here. Actually, I don't like it stacked like that. I like it stacked like that. Okay, so we have two scenes open here. We can go over and link those views just by our center location or the scale as well. So with those links, you can see now when I move the view at the bottom, which this view actually is coming from a web service, the LiDAR and the buildings and all of the base maps that are in there are streaming from ArcGIS Online into the scene. Whereas the view on the top is all local content. With just all this really is a line of sight basics demonstration that shows some how our tools work. Let's see, a couple other new things I want to show. There's some new drawing modes, so we can draw in perspective or isometric. I'll show you a slide about that in a minute. Let me unlink these views. There we go. I'll come back to my analysis view. And so in an effort not to forget analysis, a lot of time when we're talking about 3D, it's mainly just the data management, the idea of just getting the content in and placed correctly and looking good, that analysis is sometimes an afterthought. 3D is predominantly still a visual analysis, but we are doing more and more work to add analysis capabilities. One of them that I want to show today is some exploratory analysis tools that have just been released. These are essentially taking advantage of the graphics card capability to do some real-time view shed, view dome, or line of sight analysis. All right, so we can click in this 3D scene and place a view shed, or we can orient them in a number of different ways. I'll just go ahead and create one here. Before I do that, I'm going to extend my distance for that view shed. And I'm going to come in real close here and drop a view shed down. All right, I'll back out. I'll select that view shed, and I can start now editing it. Make it 3,000 feet. And so now you can start seeing in red and green exactly what the visibility is from that location that we dropped in there. Now every time I click, it drops in a next view shed or view dome, and I can create multiple ones, and they interact with each other. So it'll tell you if it can be seen by one location, it can be seen by a second location. But I'm going to delete this one for now, stretch it out a little bit. And so now we have a little live view shed of what that window can see of this part of Central Park. And now when I turn on the new plan super tall skyscrapers, we can kind of get an immediate look at how much view is being lost or gained based on those new developments. All right, so that's a live kind of graphics card driven, a yes or no answer. We can save these locations and use these in additional analytical tools. I'm going to talk about these solutions a little later, but I want to show them now. So we don't always need that visual solution. Many times we need a full analytical solution. And so what I'm showing here is a full building analysis that runs a line of sight analysis from every part of this building to every part of Central Park. We do that using some of the tasks that ESRI provides in our local government solutions. And so here's an example of one of those tasks. It essentially takes all the Python scripts and code that is required to run this solution in an automated way and packages it up as a easy to use documented workflow that can be shared with others and used over and over to get consistent results. You punch in the inputs, the various required data sets, you hit go, and you get the output. And so you can analyze in kind of real time and then also analyze in a panel by panel fashion how much of Central Park can be seen from that particular location. So it's not just about visualization, it's about analyzing and using the 3D data to gain new insights on various things. So think of property assessment, think of all kinds of visualization aspects and quantifying those as far as shadows and other blocked views and the whole issue of building super tall buildings in Manhattan. Last thing for this demo is the bookmark capability. So we'll zoom in real close to that location. Here's the Navigator here. We can drag it out as large as we need to or hide it. What I want to show here is this middle globe right here is the look around tool, and it kind of gives you a real nice precise way of exploring the scene without flying off into the distance or any of those other challenges that you would have just to look around. All right, back to the slides. So we're about almost 18 minutes in, so I think we're doing all right. Okay, lightning round. These are all the things that we don't have time to cover, but I want to tell you about anyways. And I have a little note here to say something about layer 3D to feature class. I don't think I put a slide in, but that is something I want everyone to remember. That is the tool that we use. It's in the geoprocessing tools to convert 2D content. For example, a polygon feature class of buildings that we have extruded by their height. It's still in ArcGIS Pro a 2D feature class. But what it has is those 3D properties set on it that makes it what we call a feature layer. Similar to a feature layer in ArcMap. That's kind of in-memory data plus symbology plus labels plus other properties that you can do in the desktop. Well, that layer 3D to feature class takes those and writes those features into the 3D feature based on those properties that we set in the display. So our extrusion or our setting elevation based on an attribute. Those things all get written into it and become the 3D version of that 2D content. So just an aside there, lightning round time. ArcGIS Pro has full SketchUp-like 3D editing now. You can just start grabbing and start to sketch and draw and interact with that model, cut pieces, drag, like you see in the little animation here, and all the different axes. We now support OBJ, which is a widely popular kind of standard 3D object format, in addition to Collada, which is the other most popular 3D model format. We have an edit grid, so aligning features based to the grid. So you can snap to features, and you can also snap to the grid. I built a demo last year for a Geodata Academy where we used the editing grid to create an angled polygon, an angled square polygon that used to be really difficult in ArcMap. But using the edit grid makes it really, really easy. We have geometric effects in 3D now, just like we have for 2D. So you can go in and create these various symbol effects and have full control over marker placement and some of the other 3D look of our symbology. This is what I showed before. This is an example of the line of sight tools, a number of them being laid out from one position and dynamically updating as those positions move. So I showed the view shed. This is the line of sight. Animation. We've, over the last couple years, have added an animation capability and increased the capability of it over the last couple years. Now we can have screen overlays that show dynamic text based on an attribute or a time stamp. It gives us all kinds of ability to have moving objects in the animation. I've recently been doing some animations in some Autodesk products, and I was pleased to see that we hold up pretty well when I start looking at how others are doing it as well. Isometric views, another thing that we're kind of doing to prepare for more BIM and more building and design content, and providing the context for that BIM and design content, right? So isometric views like this, definitely useful for the construction and BIM industry. We have fence diagrams now, a good way to visualize underground space and underground surfaces without kind of cluttering up the view and allow you to navigate and see the data. We have all kinds of additional tools for LiDAR. We can work now directly with the zipped LAS files. We can direct read LAS files now, so we do not have to convert them anymore into any intermediate format. You can just drag and drop them right into your scene. It's not a substitute for our LAS data set, because that has a lot of kind of plumbing built into it that allows additional capabilities for performance, particularly. Additional tools for updating Z values off of terrains or other data sets. We have a tool now that we've been working with LiDAR for so long, and the technology has improved so much over the years. We have a new GP tool that does a pretty good job of extracting automatically buildings with the proper roof shapes. That's been a challenge, and they've come a long way. So it is a way, if you have no 3D data but you have LiDAR, it's a great way to get started in 3D for very little expense. Profile graphs, being able to create these kind of side views of the elevation of the surfaces, that has also recently been added. A big thing is vertical coordinate systems. So we now support those all across the platform. I wouldn't say that much or all of the data that is out there that we use has a known one. But for the data that does, we can keep everything at the correct elevation that it needs to be, based on the correct ellipsoid and the correct geoid. Just 2 slides real quick on City Engine. It's really our product to do procedural modeling. We have a technology that's built into this called CGA, Computer Generated Architecture. It's essentially you write code to generate 3D objects of really any kind, most predominantly the city modeling, the planning worlds, and the entertainment worlds. So a lot of the movies, I won't say a lot, but a number of movies over the last few years, starting with Cars 2, going through to Big Hero 6, all utilize City Engine technology to kind of build those kind of fantastic worlds that some of these movies take place in. Some of the features in 2017, we support scenarios. So as you set up different scenarios, you can get those key performance indicators in the charts on Fourier ratios, goals that you're trying to reach as far as sustainability or other metrics. We can take 3D models that were generated through procedural code and then locally edit those to change them, make them unique, kind of add some variability into the model itself locally after generating it procedurally. And the 3D measure tools. So a lot of what you see in 3D that comes out across the ArcGIS platform is actually started as a development project in City Engine. The City Engine development team is essentially a bunch of world-class 3D PhDs that all went to like 2 universities in Europe. And they cook up many of these capabilities that then find their way across the rest of our product line. All right, let's move on now to 3D and the web and talk about web scenes and the web scene services, otherwise known as I3S. So Web 3D with ArcGIS Online really comes down to this idea or this notion of a web scene. That is essentially our 3D equivalent to the 2D web map. So you got your 2D web map that is made up of 2D either feature services or web feature layers. Same thing for 3D. The web scenes are made up of 3D services. We have the 2D map viewer in ArcGIS Online. There's also a 3D scene viewer that's used to author those 3D scenes. 3D scenes also support on the online 3D scenes, support a global and a local projection. So you can modify the symbology, you can create pop-ups, create bookmarks, you can filter and mask objects, and then you can take those web scenes, just like you do your web maps, and drop them into Web App Builder, create a story map from them, or use, say, the JavaScript API to create a 3D app, or a 2D app, or a combined 2D and 3D app. And like I said earlier, the web scene uses scene layers and additional layer types. Our 2D feature services can be draped in a 3D scene. Our base maps, our vector tile maps, our OGC, WMTS, and WGS services can be loaded in to the 3D scenes as well. A little bit more about the scene layer, what we call the I3S, the Integrated 3D Scene Architecture is, I believe, what the I3S stands for. These were designed, probably started the design of this about 4 or 5 years ago, as a web-based, kind of modern designed JSON, REST, the whole kind of modern web design methodology of our specification for a 3D streaming service. And that is intended to support large volumes of what they call heterogeneous 3D content. What they mean by that is it could be 3D buildings, it could be a whole bunch of points that we want to represent with a 3D object, it could be what they call an integrated mesh, a new data type, the kind of data that you see in Google Earth 3D nowadays, where everything's one seamless mesh, buildings, trees, everything. So there's various types of 3D content, and this I3S spec is designed to support those various different types of content, all in one spec. And they do this through this idea, this notion of profiles. So there's a profile built into the spec for 3D objects. There's a profile built in there for well-performing delivery of point cloud and LiDAR data. There's a profile built in there for the 3D mesh. And then it's extendable, so as additional types of 3D service content types we need to support, we can build a profile for those. It's an open standard, or what we would call the OGC community standard. So this is a relatively newer process put in place by the OGC for kind of widely adopted specs and formats. And so this is, I believe, one of the first ones to go through the community standard process for 3D. There's some others, I think, out there, one of them being 3D tiles that are currently kind of going through the process right now. But this one has been adopted and it's open. The I3S spec is out there. Here it is on GitHub. You can read all about it, download it, branch it, and do whatever you really want with it. There is some sample code that kind of helps some of our partner companies and others learn how to read and write to that specification. All right, so that first profile type is that point cloud scene layer designed to show, deliver billions, millions and billions of points through its caching mechanisms. A couple of partners are already kind of looking at it. We can directly create these from Pro just by creating a scene layer package for it. The publication or the way that we publish the content of 3D is the same, whether it's a point cloud, a buildings, or an integrated mesh. We essentially run a GP tool on it to create a scene layer package. It implements that data with the I3S spec, and it can be then uploaded to ArcGIS Online or just shared around with others who have our software, and they can just load it directly. So the desktops understand it, the web clients understand it, mobile, our APIs understand it as well. So this is a point scene layer where we want to deliver not a LiDAR point cloud, but a large number of points. "3D object scene layer," this was the original and initial, probably most popular, widely used one. This is for publishing 3D objects, our buildings, our street furniture, our trees, all that traditional kind of original 3D content is published as this 3D object scene layer. Here's the integrated mesh type. It's typically data that comes from sensors. A lot of drones are creating 3D mesh content nowadays. I have an example of that we can take a look at real quick. We got a little farm out here in northern New Jersey, and I'm good friends with a surveyor in the next town over from me who has some drones and has been utilizing drones in his business. So this is a farm that we have acquired permissions to go and test. So he's been able to go out and lay down survey control points. We're able to fly his mostly DJI drones. And this is the resulting type of mesh that you can get out of that. Very high resolution, all one single surface in 3D. And I will say that we didn't even really fly to get quality 3D mesh. We actually flew with the camera facing straight down, so we get really nice orthos, but we still got decent vertical resolution on the buildings and on anything that stood up off the ground. As I said earlier, all of these are published the same way. We publish them as transportable scene layer package. That scene layer package is essentially a file that has the I3S spec kind of built into it in the substructure of the file. We'll just quickly review some of the capabilities in some of these screenshots. We've recently introduced smart mapping for 3D content. So our 3D buildings, we can publish them, we can throw the textures out, and we can thematically render and map them on the client side, just like we do with 2D. Same thing for points. The same interfaces that you use for the 2D web mapping in smart mapping are the same ones you use for 3D now. Smart mapping for point clouds. So a 3D service, we can render it based on the elevation, based on the classification, based on any of the other attributes that come with the LiDAR content, intensity, etc. WMTS layer, OGC layer type in a scene, global scene. WMS, the same, draped on the globe. We've made a number of performance improvements to the spec over time. So on the right-hand side is the new speed as compared to the old. Same thing for the 3D object performance. I will say this New York City Open Data 3D model is probably one of our best test harnesses for a 3D development team. To basically try out everything they do on this model because it's large and it's got a lot of objects. 3D distance measurement. If you remember back to the screenshot of City Engine, as I said, they take that measurement capability and pushed it to online. And so those same measuring tools are available in the 3D web scenes. And when we're in a global scene needing geodesic measurements, we certainly support those as well. Some apps that are very popular out there. So this is using our JavaScript API, doing building metrics based on floors. So we have tools that will take your buildings and cut them up into floors. And then using our JavaScript API, you can build example applications like this, showing charts of various characteristics of the building, of the floor, of the inside space. Another example, using our JavaScript API and that same New York City building model hooked up to Flickr. So the filtering on the bottom allows you to just filter the buildings graphically by the height. You just grab that bar and pull it down. It shows kind of a dot mapping of all the buildings, as well as other filters that you can apply. So client-side filtering of the content, client-side rendering, all with good performance. All right, solutions for 3D. I got about maybe 13 minutes left, so I think I'll be able to get it in. For many years, ESRI has had a solutions team that main role is to create what we call these ArcGIS for local government, or ArcGIS for state government, or ArcGIS for utilities solutions, which are kind of best practice workflows that we've acquired over the years from working with our customers. About 2 years ago, we got a new company-wide 3D product manager, a guy that came over to us from Autodesk. The guy that was the 3D product manager became the main 3D solutions developer. His name is Gert, and he's based in New Zealand, and so I have frequent calls with him on kind of developing some of these 3D solutions. And the ones we're going to look at are the ones that are available now. The ones highlighted in red, review proposed developments, and local government scenes. All right, so what are they? They are ArcGIS Pro projects, so full project download. You get a requirements, it tells you what you need, what you get, what's new. You can download it, or you can view the live web scene. You get sample data, you get the tasks the toolboxes and the Python scripts, any procedural rules, or any other content that you need to run the full thing. You get the data so you can open it and run through the entire workflow with the existing content, see how it works, and then adjust it to use your content. Take a look at that page real quick online, solutions.arcgis.com, local government. Those solutions can be a little tricky to find. I normally, you got to come to the third one here under planning and development. And so you have your 2D ones that we've had out there for a while, photo inventory properties, notify owners, etc. Down here at the bottom are the published 3D base maps and the review proposed developments. So each one, you can learn more. You can watch a YouTube video of how they work, visualize proposed developments, conduct visibility assessment. That is the one I showed earlier in ArcGIS Pro that created those sight lines and did that building visibility assessment panel by panel. So you download it and you have the same tools that I used to do the one for New York City. You can just launch the scene and see what it looks like as an online web scene. You can see in this example they're doing a new building and its visibility to the river. And it quantifies that panel by panel by panel. This panel is a user-determined size. So the number of sight lines of the river that it can see. I talked about the review proposed developments. There's also the local government scene. So overall, these are my recommended foundation for starting 3D GIS. This local government scene starts you off with what they call a basic local government scene. It has the tools in there to take your LiDAR data and extract buildings from it. It extracts trees. It's the very most simple version of it, just simple mass models and analytical models of your content. Schematic local government scene adds additional detail, adds detailed elevation, kind of another step of resolution up. Realistic takes that one step further to create realistic trees, facades on your buildings with textures, etc. That looks a little bit more realistic. Whatever you create using these can be fed into these solutions. Review proposed development, do your visibility, your solar impact. Quick note, this evaluates shadow impact and solar impact. We had a customer ask us they need to do a solar analysis of all their street trees. So I called the guy in New Zealand. I said, let's take the one solution and just modify it to do it for trees. And he said, no problem, I'll release it by the UC. So you'll see one out there in a couple months that you can plop your street trees in and get a solar calculation for those, taking into account buildings and shadows and everything else in the 3D world. BIM. Building information modeling, building information management, building information, there's all kinds of acronyms people use for it. I typically use building information modeling as a traditional term for it. Currently, our CAD and BIM support is pretty good. We do support, and I've personally brought in Revit models to ArcGIS. It's not the best flow. I'll show you that in a second. But we do support it, and CAD as well. So one of the things I want to point out is our recent update to ArcGIS Pro now will export CAD mesh objects when we export to Autocad. So now all of our 3D content that we have can be written into a 3D object for the Autodesk file types. So I can take our 3D buildings and give them to an engineer, and he can use them in AutoCAD. ArcGIS for AutoCAD is a free plugin for AutoCAD that we've had out for probably almost 8-9 years now. It allows you to essentially georeference your CAD data using ESRI projection systems, to take CAD layers and assign a GIS feature class to those. So that from that point on, when the CAD people are doing their CAD and selecting the layer and drawing their objects, in the background, it's creating GIS features. So a really good way to get people using GIS that don't want to use GIS or just want to continue doing CAD. And then an ongoing effort to enable users to work with BIM. Currently, this is the workflow for bringing BIM in. We either use Revit and use the plugin from Safe Software, or use the industry foundation classes, which is a standard in the BIM world. Then bring that in through the data interoperability extension, run some geoprocessing on it to break the walls out, to break the roofs and all the other Revit elements and families out into useful GIS layers. A doors feature class, a floors feature class, a walls feature class. It's in there now as 3D objects and 3D GIS content that is then available across the rest of the enterprise. What we're hoping to get to is to get rid of this lossy workflow. We lose textures. We lose a little bit of attribution that's on the Revit side. And so that's what we're trying to get rid of, and looking to just directly read Revit, just directly read Civil 3D. And we can bring those buildings in directly with full content, with full textures and other materials, and bring those directly into our stuff. On the flip side, we want to be able to see the design process, right? We pull from our official source of record for elevation, for other as-builts, right out intelligently to CAD, and they can utilize our content to get started. And that's really the high-level idea of what we're doing with Autodesk, right? So big improvements coming. We're going more inside of buildings. For me, 3D and BIM is the motherlode of GIS content, right? It's accurate, it's precise, it's rich, and it's where most of everything happens in the world. So we're doing a lot of work to go inside the building, to navigate, to work inside, and to perform well with those volumes of content. Additional things we're doing, we are expanding our information model to more support BIM type of content for both traditional BIM and non-traditional BIM users. So a project manager of the city or an aviation division isn't a BIM user, but they need to see, say, a dashboard of the progress of that capital construction project. Doesn't necessarily have to be in an Autodesk app that's built for engineers. It can be in a 3D web scene that's a little bit more usable by non-professional types, at least engineering and architecture professional types. So in 2018, we are looking and actively close. I think we'll be hopefully releasing this by the UC as directly reading Revit as a data source in Pro, and delivering that BIM layer experience, that initial BIM layer experience in our software. Real quick, just because I got 3 minutes, I'm going to take us up to 50 minutes. We've done and have worked with BIM in the past. So here's an example. Here's a web scene of the Atlanta airport. I'm going to close some of these others. Well, first of all, quickly, the Manhattan Skyscraper Explorer with the live filtering. An early prototype of integrating a 3D web scene with the Autodesk A360 kind of cloud platform. So this is their platform for viewing BIM content online. It's going to upload your model to their cloud platform called, I think it's BIM 360, and then we've integrated the model with a web scene kind of allowing you the two types of views, the engineering view of just the BIM model, and then that view in context at the site. I'll launch this to show another example. Very large implementation of a 3D web scene for the Atlanta airport. This is Terminal C, which is a Revit model that they used. It was renovated a number of years ago. So I'll click on something and you can see that's the name of the element in Revit. I brought across this little ID here is what they call the Revit instance ID, and that's how we connect it back to all the Revit attributes. So a BIM model in context you can go inside that and take a look at the interior spaces. I'm just trying to watch the screen sharing to see when this actually finishes loading up. And then the widely known underground people mover area. As well as the first U.S. service of the A380. So anything can be brought into these web scenes. This A380 I bought from, I think it's called Turbo Squid. It's a gaming site. You buy models to build your 3D, your video games out of. They're nice because they're highly efficient 3D models that work in all kinds of other places that aren't video games. Okay, to wrap it up, so last November, I think it was actually GIS Day, Jack went to Autodesk University, which is their big conference, and announced a big partnership. Right, so now everyone can make anything with the science of where. Not my words, some marketing guy's words, I think. But what that really breaks down to is what we see as this this wheel of design in the life cycle of infrastructure. On the left being GIS, on the right being BIM, and the touch points are really these blue lines here. And where we move from GIS, where we start kind of in that traditional master planning, regulating and permitting, and then we get into this preliminary design and then planning, is where we see providing that site context, providing that digital twin content to the BIM world so they can start their preliminary design in site context, right? With all the right information they need to make the right design decisions. And then it goes into their detailed design, their Revits, their civil 3Ds, through pre-construction. And then we start looking back at these touch points on the return side where we can start capitalizing on that BIM data for virtual construction, showing progress dashboards as the 3D thing is being built. We show the dashboard and the progress in 3D from the BIM model. All the way through commissioning of that building, where those as-builts are handed back off for the people that run and manage and maintain the building through its full life cycle. And so the blue line and the orange line, the thin one arrows here, are essentially where we're doing our R&D work right now on connecting our two platforms. Right? I can't really tell you all that much more because it's somewhat of a work in progress, but I can say that you'll be seeing the ability to read Revit content. You will see the ability of some of the Autodesk products like InfraWorks. Nope, I'm back. I was muted, I think, but I think we went into Q&A mode anyway, so that's actually right where we need to be. So I don't know if I can. All right, I'm not quite sure the audio is working for. Oh, I see a question coming in. Hold on. Is it possible to edit in Web 3D? Not quite yet. You'll initially see a capability of editing attributes, but as far as editing 3D geometry online, not quite yet. I got a question from Al. OGC is currently doing a project to integrate underground infrastructure and soil layers. How do I see this fitting into our 3D plans? I see it fitting very much so into our 3D plans. We will essentially just adopt that OGC data model and look for any gaps that may or may not exist. For us, it's a data model that's implemented on a database. We'll connect to it from there and visualize it at whatever elevations the data requires. We are actually engaged with the city right now on a prototype regarding that underground utility thing. We're actually hoping to chat with you about that at some point. So reach out outside of this call and we can definitely discuss it more. Any other questions? Excellent. Well, we have about 2 minutes left, so we can now just hang on the line. Otherwise, I thank you for attending. I'll just relate one other thing about this Autodesk thing. So on a call yesterday, some of the Autodesk's execs were telling us about this huge infrastructure gap that exists, and that the number of buildings and the infrastructure needed to support the amount of people in it is not nearly enough. And a lot of things are going to need to be built between now and 25 years from now. And we're hoping that this kind of partnership makes the work required to get there much more efficient, much more realistic. So there's large opportunities in that realm of closing the infrastructure gap that I think a lot of us are well positioned to take advantage of. Dakota has a question about integration between Revit and ArcGIS. We'll initially be reading Revit models, I think, this year, most likely by the user conference in June. I've seen personally a prototype of us reading directly Revit content. so we're not years out, we're months out. Initially, you will see a standard set of Revit elements being supported. The standard ones that you find in Revit, all the structural elements and some of the architectural elements, with additions to that over time. Still kind of a fluid development cycle that we're on here, because we're actually still kind of deciding what's most important and figuring out what resources need to be put where. Any questions? Yes, the presentation is recorded, and I'm not sure where you can access it, but I'm guessing the New York State Association website or some link from there. And then just for anyone, mostly Al, who wants to stay online, I've shared my screen again to show you just one of the latest web scenes that we've developed for underground infrastructure map. So if you got the data, we can put it where it lives and render it however we want, based on standard utility colors, definitions, or something a little bit more realistic, like procedurally generated manhole that is driven off of real specs for what a manhole is. And we can do that in a profile or a full kind of way, and all connected to its utility model attributes. So with that, I've gone 2 minutes over just because I always go over. I had to again. So thanks again, everyone, for attending, and I hope to see you guys around the next year or two.